Whether you're hyperconnecting your ecosystem, empowering a distributed workforce, rapidly leveraging cloud, IoT, AI, or other new technologies, RSA is here to help you manage digital risk your way at every stage of your journey.
Good day, everyone, and welcome to this session where we're going to talk about API security. I'm Joe Crow, a senior analyst for IT Group. We're an independent research organization. And for 2020, we did quite a lot of research and reporting around API security, and I'm pleased to share the results of that research with you today. So why should you care about API security? Well, the reason why is that APIs are just absolutely exploding in our modern enterprises today. Last year in 2019, an organization called Nordic APIs, which is a community of API developers, they estimated that there were more than 15,000 APIs in use across the globe. But what's happened in the last year or so is that the use of APIs has absolutely exploded. Because of the COVID-19 pandemic and the use of automated workflows and chatbots and all different kinds of collaboration tools, no one really knows how many APIs are actually in use today, but empirically, it's somewhere around the range of 100,000 or more. So this is an area that is absolutely growing, and there's a guarantee that if it hasn't touched you, it's definitely going to touch you in the future. An interesting statistic from Akamai came out that said 83% of all internet traffic is somehow related to APIs. We thought that was quite astounding, and the more we pressed on it, the more we believed that to be true. What are APIs being used for? Well, they're really the backbone of the digital economy. And we have something in Europe called open banking, which is a regulation that requires banks to be able to share information and open up to fintech companies. That's driving API use. Also digital transformation programs and initiatives, and even IoT deployments and the driverless cars. You can't run a driverless car without using APIs. So we found that during our initial research that most enterprises have more than 600 internal and external APIs present in their environments. But we found as we started our research in early 2020 that security awareness around APIs is actually very low, and it continues to be very low. So we started off with an interview of 20 CISOs, security architects, and digital transformation specialists. And we just simply asked them, how many APIs are traversing your networks and your environments? And they really didn't know. So at last year's RSA conference in San Francisco, we actually did a lot of discussions with security professionals. Those were both scheduled and ad hoc. And this question kept coming up. And we found that a lot of people that probably should have known did not know, and there was a very low visibility around APIs. So another thing that we found out during our conversations and interviews is that there was a general assumption that traditional security products like firewalls and load balancers and web application firewalls were providing sufficient protection against APIs or API attacks. And even there was a misconception about what API gateways do. And so based on that, we published an initial report that talked about lack of visibility around APIs, and I'll touch on that in a moment in a case study. But after we finished that first report and research, we kind of decided, let's go talk to the people that are actually creating and managing APIs. So over the summer, we did interviews with 53 application developers and security professionals representing 31 different companies. These were mostly in fintechs, insurtechs, and financial services organizations, where we assumed that the level of security would be quite high. And to be able to compare apples to apples and oranges to oranges, we came up with a methodology where we came up with a way to come up and measure the maturity scores against 7 competencies. And we're going to share that with you in just a few minutes. But the bottom line on that secondary research was, again, we found API security awareness to be very low. So what are the threats? Well, attackers are going after APIs for one primary reason and a couple of secondary reasons, but the main one is there's a low probability of detection. They're able to manipulate APIs and use the API streams for all kinds of nefarious purposes because most organizations have this limited visibility and very few capabilities to disrupt that attack surface. So what are they doing? They're stealing sensitive data. They're messing with business operations, manipulating data streams. They're taking advantage of the ability to abuse business logic, get unauthorized access, and even do denial of service attacks. So there are lots of threats to APIs, and that's why our mission is to try to raise awareness and help people understand that if you're not securing your APIs, it's probably just a matter of time before you'll have an issue with them. So one of the other things we learned is that this is not something that we're talking about nation state attacks, and we're not talking about sophisticated cyber criminals. Actually, you can do API attacks without having a high level of expertise. And you can buy tools or you can get them free. A lot of these are no-cost tools, and you can get them in the hacker marketplaces. They're widely available. Attackers can use proxy tools. They can even get services. They can get low-cost services to be able to support their attacks. And the folks that develop these tools actually update them on a fairly frequent basis. So if they are detected by certain products or solutions, they can keep avoiding those detection modes. And again, at the RSA conference last February, I was able to see a 15-year-old high school student do a live API attack against a gift card database. And based upon his description, this is not something that requires a high level of expertise. And if you just Google any one of these tools, you'll find out that they are really prevalent in the domain, in the marketplaces, and the places where hackers go to get their tools. So we're not talking about small organizations that are being breached or having to publicly acknowledge their vulnerabilities. We're talking big companies like Cisco and Google and Facebook, Twitter, Salesforce, Zoom, Waze, and Amazon Web Services. Venmo had a particularly damaging incidence of an API vulnerability. Also in retail and hospitality, also in the automotive space. And the most recent attack was a few weeks ago, was one of the dating services that was a mobile application. And they were, because their API was not properly configured, you could actually extract from the database all kinds of user profiles, or you could upgrade your service without paying for that premium service. So these are just examples of API attacks. And public service as well. The most recent one was the Biden for President campaign had a very interesting app for managing their potential voters that suffered from a number of API vulnerabilities. And we have also seen in recent weeks that a lot of the COVID-19 tracking applications, which have been pushed into the marketplace very, very quickly based on need, also suffer from API vulnerabilities. So this is an example of one that was found as part of Uber's bug bounty program last year. And in this particular case, what happened was there were a number of security issues with the API, which allowed the attacker to actually enumerate all different kinds of information within that database. They took advantage of the fact that there was really poor authorization on the APIs. So just simply by intercepting the stream, you could do a lot of things with the APIs that you really shouldn't do. The attackers could have been able to see from the error messages all kinds of sensitive information. And what they did was an enumeration attack on the part of the application that allowed you to add a driver. by simply manipulating that API, they could actually pull information from the fleet manager and get access to all different kinds of things about the existing drivers, like their email addresses, like their phone numbers, and all other kinds of sensitive information related to that. So this is just one simple example of an API-based vulnerability that could have resulted in a pretty significant privacy and or security issue for an organization like Uber that really relies extensively on APIs for their application. So what do we do about this? Well, as I mentioned before, I can confirm based upon our research that firewalls, load balances, and WAFs just aren't giving you sufficient visibility into API calls and traffic flows. But there's good news here. There are a number of solution providers that are rolling out new products and new solutions. These are API security gateways, which we did a report on in the early part of the year 2020. We're seeing the ability to use artificial intelligence to do traffic analysis on APIs, and also services that you can do discovery and all different kinds of ways to protect your APIs available as a web service. But from our first bit of research, we recommended that organizations just simply make API security part of their cybersecurity strategy and acknowledge that they're going to need to go beyond the traditional cyber defenses if they intend to provide more protection against API-based attacks. So a quick case study here. I had an opportunity to speak with a security professional at a large financial services company, $1 trillion under management, and more than 20,000 employees. And their issue began in 2018 when they were seeing what they thought were credential stuffing attacks, where attackers were using big stores of credentials that had been compromised in previous attacks, and they were sending these in, trying to go against an API endpoint until they found one that would give them access to the infrastructure. And what they did when they saw these credential stuffing attacks, they had all different kinds of manual process and technical controls, and they would spin up incident response, and they would open up bridge lines. But really, they didn't know what was happening with the API traffic. So they had very limited ability to do anything about these attacks. And they kept changing time of day, going against different services. And what happened was in the first half of 2019, not only their web applications were impacted, but then it extended to their mobile services as well. So the security professional I talked to said that for the better part of a year, they were running around playing whack-a-mole, trying to deal with this different type of attack. So what did they do? They instituted an API-enabled traffic analysis product, and they put it as a sideband deployment to an API gateway that was already in their environment. And shortly after they put that product in, they were able to see indications of the attacks against not only cookies, but also against tokens. And this gave them a lot of intelligence about where they needed to go shore up their defenses. And the product that was looking at this AI-based product that was looking at their APIs, they were able to produce alerts and send those to their Splunk platform and create all kinds of new use cases related to API abuse. And this gave the security team a lot of not only visibility, but a lot of capability to rapidly respond to when they saw things that matched these use cases. And what also happened was an unintended consequence. They were finding all kinds of network issues. For instance, they found that there was a troubleshooting application that was supposed to be disabled when the application went to deployment, that somehow never was disabled, and it was constantly running tests against the application, which was impacting performance. And they found that through this API visibility capability. So what happened was they raised awareness of API security by deploying this solution, and they felt like they were in much better stead to actually do something about it by implementing this solution. So in the summertime, we decided, let's go look and see how API development practices are done. So what we did there was we created this methodology. We looked at, what are developers doing with regards to APIs and how are they actually creating and how are they managing them? So based upon the interviews, we also looked at documentation, we looked at presentations, we looked at all different kinds of materials to be able to assess maturity against 7 API competencies. And because we wanted to be fair in our measurements, we used the Carnegie Mellon CMMI, which is a rating schedule that you can be able to address maturity. And at the end of our research, which took place over about a 2.5 to 3 month period, we really found that security awareness, even regarding what kind of attack trends were out there in the environment, was very low. It was low at financial institutions, and it was really low at fintechs and insurtech companies, which tended to be smaller, but were creating these very powerful APIs. These are the 7 areas we looked at, and I'll go through each one in detail. But we felt that it was important that an organization have a central point of contact for API security. We wanted to know, were there tools or methods to manage the inventory of internal and external APIs? Is there a defined process to consume APIs from third parties? Does the company follow application security practices, and do those include API security specifically? Do they publish an API catalog, or do they offer an API development portal to allow those that consume the APIs to be able to implement them properly? Do they have a security training program, and does it include API specific content? Does the company have a process for handling security incidents, and does that include AppSec and API security criteria? We felt that these 7 areas were a good benchmark for how does the organization manage specifically API security related issues in their environment. So the first one. So we asked, is there a designated API security point of contact? And we found that only 1 company of the 31 that we spoke to actually had a designated point of contact. 17 companies said, no, and we don't really have any plan to appoint a point of contact. 13 said, well, we have a decentralized model where API creation is done in the various teams, and it's kind of spread all around the organization. So each team is responsible for their own APIs. And we felt that from a cybersecurity standpoint, from a risk standpoint, that lack of a champion can have developers doing bad things, like trying to implement APIs in a way that's not secure, or maybe to contravene policies of the organization. So we rated them about medium scale on this, repeatable, but there's certainly areas for improvement. So do you inventory your APIs? And this goes back to the visibility question, now from a creation and implementation standpoint. So nearly half of the companies we spoke to, they couldn't tell us how many APIs that they had created or deployed or were managing. They kind of had a rough number, but no real inventory. And 13% had no inventory whatsoever. They say, well, we create them, we manage them, but we don't keep track of them at all. So we saw inconsistencies between the use of external and internal APIs. So we did see one area that we considered to be a best practice. There was an organization that says, we treat all external and internal APIs the same way. We put them through the same security controls and rigor regardless of whether they're internal to our organization or exposed out to partners across the internet. And the reason they did that, they said, well, in a fast moving business environment, an internal API can quickly become an external API. And they just treated them all the same and applied a very high level of rigor to that. We thought that was the best practice. But still, because they're not keeping track of the number of APIs they're creating, this poor visibility can really contribute to cyber risk. So our third question was, do you have controls for third-party APIs? And 19 of them were actually doing some kind of due diligence on their third-party providers. 10 companies did it on a case-by-case basis, but 2 companies we spoke to said, we don't do any due diligence at all. The developers go out, they find the API they need, they contact the organization, and they integrate these APIs into their products. So what happens there is if you're implementing third-party APIs, it can really have an impact on the performance if they're poorly coded or they're not properly implemented, and that can also increase cyber risk. And another thing is that if you're an attacker, you can pose as a third-party API provider and you can slip into the stream and start to do pretty bad things. So controlling third-party APIs is something that we felt was something that organizations should really scrutinize. So we asked, do you perform application security testing? And the good news there is, well, all 31 companies said they performed some type of AppSec testing. So we thought that was a great idea. And we saw both DevOps and agile environments or hybrid environments with different teams using different methodologies. Interestingly enough, we did find companies that were doing threat modeling, which we thought was a best practice, and 2 actually had bug bounty programs. But of the 31 companies that we spoke to, 26 of them were not specifically testing their APIs. What they were doing is waiting until the product was done or the API was complete, and they were doing penetration testing. And it was our feeling that finding these things during penetration testing just shortly before going to production or making the API visible was probably too late in the development chain to really have much impact on it. Next, we asked, do you publish an API catalog? 15 of the 31 companies said they don't publish a catalog, and we don't provide a development portal to help people implement the APIs that we create. So why do you want to do this? Well, you do catalogs so you can help your own developers quickly find out what approved APIs are already available within your organization. And development portals actually help your customers or your users. You give them guidance on how is the best way I can implement this API and how should I secure it. So what happens when you don't have it is that a developer may go out and create a duplicate or similar API. And because it's duplicate, it doesn't go through any kind of proper testing and approval. And we found that one of the biggest issues with development of APIs is that the developers continue to have questions or issues or challenges related to authentication and authorization. And this is an area that can really be problematic, both from an API creation and a management standpoint. So we asked about application security training, and we saw a wide variance in how training is done for developers. 14 of the 31 companies said, well, we do training, but it's really high-level training. It's compliance. We do it because our customers require it. It really doesn't provide much in the way of AppSec guidance. It's mostly around what are the company policies and password management and stuff like that. We really didn't feel that that was going to be sufficiently targeted for creation of APIs. 13 of the companies specifically mentioned that they use the OWASP Top 10 in their training. But interestingly enough, only 2 of the 31 companies we spoke to said that they were aware that OWASP had actually come up with a separate top 10 for API security in 2019. And they were quite surprised when we pointed them to go to look at that resource. None of the companies that we spoke to provided any API security specific training to their developers. This was one of the more interesting findings from our research. Not one was providing any API security training. So, do you have methods to identify and report security incidents? Well, 9 of the companies had pretty good documented processes that we heard of and we reviewed, and it was good for handling security incidents. It was good. Some of them even had RACI charts, and they had call trees and all the things you would expect when you were talking about identifying and reporting security incidents. But 11 of those companies say, well, we don't have anything like that. We'll just handle these things as they pop up. And 10 companies didn't have anything at all. In fact, it was kind of foreign to them to even consider that they needed to have processes for handling security incidents. None of the companies we spoke to and none of the materials that we reviewed had any guidance at all specifically related to APIs. So 2 companies said they had actually had API security related incidents that had been reported to them. They didn't find them, it was their customers that found them. And 20 of the companies, 20 of the 31 said, yep, we had problems, but we found it during third-party penetration testing. And as I say, that's pretty late in the process to be able to find vulnerabilities. So our recommendations, ways to improve API security. These were the things we put in our reports. We think that every organization that is either producing or consuming APIs should have a knowledgeable representative for API security. We think that organizations should implement an API management platform. This is beyond keeping track of APIs in spreadsheets or other manual means. There are tools that you can use to manage your APIs. We believe that they should conduct thorough due diligence on third-party APIs. They should implement an API catalog and developer portal. It's not as hard as it sounds. Organizations should expose all developers to API security concepts. And this includes what kind of attacks are out there, what are the methodologies, what are the tactics, what are the procedures that the attackers are using. To be forewarned is to be forearmed. And to create and disseminate procedures for security incidents and include API-specific details in there, such as if there's an incident or an anomaly that is tracked to an API, how do you quickly identify who developed it or who is responsible for managing that API so you can do troubleshooting and or take the necessary measures to stop that particular attack. And finally, to include API security testing as part of the software development lifecycle. So these were our recommendations. We hope that we've been able to raise awareness around API security because APIs are going to continue to be used all across the infrastructure, all across different markets and different verticals. And now is the time to start to focus on how to protect them. So I encourage you, if you have anything you'd like to go deeper onto, you want to enter that into the chat window, we can discuss that as we go along. So I thank you very much for your participation today, and I look forward to additional questions and additional conversation around the subject of API security.